All right, we're going to get started here in another minute, but for those that are just joining us, make sure you get scanned to get one of the tickets for the giveaway at the end of the session. But we'll give another minute or so before we start. Awesome. Mhm. All right. So, yeah, like I mentioned, for those that just joined us, be sure to get scanned. We do have a raffle for this 4K Fire TV at the end of the session. So there's no quiz needed. So it's definitely just a raffle. We are going to be talking a little bit about API hacking, specifically around the Meraki dashboard and how to leverage that against both Meraki networking and Catalyst. My name is Nico Darrow, just to kind of brief you. I'm a senior TME for Meraki. Before this, I was in Enterprise Premier doing a lot of API automation. So I want to share some of the really cool things that we figured out we've been working on to facilitate some of the larger scale needs for API and automation. So for those that don't know, Meraki is a cloud platform, right? This is basically the full range portfolio. What's great about the API is that you don't need direct access to the device, right? We've always talked about API previously, programmability. What's great about Meraki is that you can do everything in the cloud, and everything gets programmed, even if the device is offline. So provisioning day two, it becomes very powerful. And we always talk about this API strategy, but I'm going to show you and provide tools by the end of the session that you guys can use. If you guys have Python experience or have used API before, this is a way to level up where you don't have to learn anything new outside of just inserting code into a template script. All right, is this a little bit better? Yep. All right. All right. Now I'm going to be shouting. All right, so this is just just a quick overview of what we're trying to do, right? The idea is I want to take a use case outside of just day zero provisioning, right? Because that's a very common one. Deploy new stuff, that's great. But what about using the network as a sensor? I've had customers that had 17,000 plus locations, and they want to do a simple I want to see what clients are connected to my network throughout the day. That usually takes an hour or two to run these reports, and that's not efficient, especially at scale, right? API is great, but then once you start bolting on capabilities, it becomes more complicated. So what we want to do is show you some tricks to simplify this and actually leverage it for both reporting, configuration, and of course, as you onboard Catalyst, if you have cloud monitoring for Catalyst or full management, the same hardware platform and the same endpoints that we're going to show you work for that as well. We had a great use case where we're looking for bad fiber runs for a customer. We're able to look at all the CRC errors historically, look for downward trends across not just Meraki hardware, but also Catalyst. So let's take a look at a script, right? So you don't have to know Python. I want to kind of give you a little bit of overview of what a regular script looks like and what we're doing differently. So if you look at a traditional script, you run it sequentially, right? So you're going to go through and say, hey, get all my organizations out of each organization, get me the networks. And you can actually see here that if you look at what it costs time-wise to run a command, it takes just to get all the organizations, it's like half a second. And then for each organization, get the networks, another half a second. And if you know our API limitations, it's 10 calls per second, right? That's not new, but I'm going to show you how to get way past that, right? Close to 100 per second. But this is not going to get you anywhere close to 10 per second if you run traditional API scripts, because there is overhead on a call, right? You've got to do the HTTPS call, there's a response, and your 10 calls per second will actually be between 2 and 3 calls per second. I actually also built a tool that I'll give you a link to where you can actually look at your existing scripts and see how optimized they are, and then see if you can benchmark it, right? So this is a traditional script, and we're going to use a very simple use cases. Like I want to look at all my organizations, maybe not just one, but many. And for each one, I want to find out which networks are in there. And for each network, I want to look at what the clients are. Now, this is a very simple use case, but it's very cost intensive if you're doing a traditional script. because you're going to be looking at, a problem where you're basically waiting for the last result to come back before you get the next result, because Python is sequential at the end of the day, right? You can't really run parallel tasks. Now, there is something called AsyncIO. So this is the ability for us to run queries in parallel. Now, we've had this for a while, and we've had some code out there, but it's very difficult to implement, especially if you're running Python. It's weird to wrap your mind around the concept of AsyncIO. So this library that I'm going to give you, a starter script, is going to simplify all that for you, so that you can just keep writing traditional synchronous code and get the benefit of it. So AsyncIO is a Python library that is a wrapper of our Meraki library, the dashboard library, and it allows you to run things in batches, where you don't need things like, if I want to say, okay, get me this client details and then make a change to that client, you're going to want to do sequential, right? You can't really say, give me all the clients and then give me all the applications. So this is the way we do it, to get things in parallel. And I want to give you a better visual example of this, right? So if you look at how a traditional script runs, right, you're going to say, get organizations, you're going to get the data. So this is the result. This is another get networks, get the result, and so on, right? So you're hitting each queue. Now, what happens if you have an error, or like for some reason your Wi-Fi roams and your script fails somewhere here? Now you've got to rerun and start from the beginning. So it becomes non-enterprise or non-scalable to be able to have these scripts break, right? So you're going from a bucket by bucket to, with AsyncIO, you want to look at something more in a batch mode. So the way this works, and AsyncIO, if you want to think of it, is it like you're getting an IOU. So it's the same function. You query the function and it returns a result, but that result is a future object. I like to call it like an IOU, right? Like in the future, that'll be worth something, right? You want to keep that one with the Lamborghini, right? The 400K. And the idea is, like, instead of doing it sequentially, I want to do everything in one. Now, this is the traditional way you use AsyncIO, where if you want to say, okay, for every network, instead of querying network by network by network, I want to query all the networks at once, and then I get the data back, whichever comes back first. That's great as long as all your objects are the same, right? Now, if I'm querying, RF profiles or something different, your result may be different, So this is where it gets complicated. But the idea is, you run the same function, you have this future object, you wait a period of time, and it eventually becomes real data, right? So what we want to do is take all those objects, put them in a bucket, and then we get all the data at the end of the day and then populate it. Now, this is great, like I mentioned, for one function or one type of task, getting the networks. Now, you'll end up with the same accordion effect, where you're getting all the networks super fast and then you're slowing down. Now you're going to get all the clients super fast, you're slowing down, but you're not going to have consistency. So I came up with this concept called trash packing. It's a skydiving term, actually, where you're looking for the fastest way to get the data done and still have it organized. So I built this concept, or at least in the script, where you can actually tag the return function with what you queried, so that you know that it's, this is a network client table, or that's a RF profile table. So you can essentially take all those future objects, and put them into one bucket. And that, the bigger the bucket, the faster things are going to become. And I'll actually have a demo that's pretty impressive. So, and you don't have to worry about sorting this out. So the idea is, instead of querying network by network, I want to query everything, like just everything, star.star, which is going to be significantly faster than just querying like 3 networks. And it's a way, you have to wrap your mind around it. But if you wrote an async function, you'd have to change the return a little bit. And there's a lot of complexity to it. So instead of worrying about this, we're going to do this on the front end of the script, right? So I want to kind of get to a kind of the Oreo of the script, where on the front end, we're using AsyncIO to query, get all the data. We're going to process it with normal logic, because it's all going to be memory based, so you don't have to worry about timing. And then we're going to use something called ActionBatches to post it. And that way, you're doing acceleration on the front end. You have your logic, so you can take your existing code, just drop it in. And then at the end, we're going to do action batches, which I'll show you is a much safer way of making changes. Because the other thing, too, is like the bigger scripts I see out there, like you get halfway through and, oh, man, we changed an endpoint, or you have a bad connectivity and now your script crashes, halfway through a script, and you have some committed changes, some not. So you've got to build logic into your script to, verify stuff. That's way too complicated. So I'll show you this in a second. I want to just show you the demo, right? So the idea is, like, we want to be both reliable when we run scripts, especially in production. We want to be able to run scripts with other scripts running. So if you have multiple engineers and they're both programming, you don't want to run into an environment where now your script breaks on Tuesdays because that's when someone runs a backup. And this is where I'll go into the demo. And this is a really cool demo. I'll have the link to this in a bit. And this is going to, I'm just going to start running this API backup. And I'm going to say, no, don't run AsyncIO. It's going to take a little while, so I'm going to talk to it. So what I'm doing now is I'm running this was actually a customer use case where they wanted to back up all the API usage, for all their organizations, and they had 43 orgs, large hotel chain. But they wanted to look at 60 days of API queries and all the logs. They wanted to download that every day. Now, this process normally took like 4 hours, right? This is just an example of this running against my org. I have 3 organizations, a lab environment, and it's pulling essentially 12-hour batches of API logs. It's a lot of records, right? And it's doing it sequentially, which means that you can see here as it's going through each org, it's saying, give me all the API queries for this org, and then this org, then this org, but for this day, and this day, and this day. And you'll find out that it takes a significantly long time to run. And if there's any sort of Wi-Fi error, hopefully not, you'll see an error in it and have to run it again. Now, the other thing too is you don't want to, if you query the same thing twice, I say you're doing something wrong, right? Especially in a script. You don't want to say, query the network, then do something, and then, well, let's query the network somewhere else, right? I like to, in the beginning, you query everything. And if you guys are familiar with Pickle, which is it's a Python library for taking an object, serializing it, and put it on disk. It's a great way to cache a whole bunch of stuff, clients, information that may take an hour to run, pickle it all in memory, and that way you can work on that data on an airplane, or later you can see if there's any data differences. So this is going to take about 3 minutes to run. I ran it a little bit earlier, but I just want to show you the differences. And this is also, when I first got into AsyncIO, I was like, this is great if I was running multiple servers or if there's a way to distribute it from source IPs. But this runs incredibly efficiently from a single IP, from one laptop here on a Wi-Fi in a convention, right? It's a little bit slower because we're in Australia, but the proof point is still the same. So, and don't worry, the rerun of this is significantly faster. And this is great for anything, right? So this is just one use case. I've got customers that are using this to do a port-based configuration backup hourly, right? Because they're a large airline that has switches globally. They just onboarded a bunch of Catalyst 9300s in monitor-only mode, so they're running as is. But when they connect to dashboard, they basically uploads the last known config. And what they want to do is say, okay, I want to back it up so that if that switch ever, gets whatever RMA'd, I can just quickly put the last configuration on it. And it's a great way because you don't have to wait for the device to be online. You can do everything while it's in dashboard. So, and what's great about this script is every time I run it, it actually gets longer because I'm using API to query the API queries. So it's kind of like Inception, but with better GitHub repos. All right. So, and at the end of this, I'll give you both a link to the GitHub repo for AsyncIO Benchy, which is it's a benchmark tool where you can both use the tool to look at the logs for your existing scripts, and even like old scripts, it goes through and looks at how many calls you actually submitted and got back. And that way, if you start messing with this, you can actually see if things are improving or impacting performance, right? Because it's a great way to tune that. So you can just see here, so it's longer than 3 minutes now. It's at 205 seconds. And that's to query 25,567 API records. That's full API query with all that. So that way, if you have to do, off-site backups and stuff, it would take you just over 3 minutes. Now, what does AsyncIO do for us? You don't blink, right? Because this is slightly faster. So from about 3.5 minutes to almost 5 seconds, right? And it's actually slightly faster if you have better connections. So that is essentially the same, right? Still 25,647. So we got 70 API queries new since the other one. But this is just the power of what AsyncIO can do. And this is a get, right? So this is querying the data from your network, leveraging your network as a sensor, client applications, neighbors, rogue APs. The possibilities are endless. Now, the other tool that's included in this little demo that I'll give you is this log analyzer. So you can see here, I'm going to look at my logs, and these are generally generated from a Python, the dashboard API, and you can run the log analyzer against it. So this is also from the same repo, and it'll tell you I was doing about 1 call actual speed, right? Nautical miles per se, right? The 1 call per second, realistically. Meanwhile, with AsyncIO, I'm doing close to 40. Now, the more orgs you have, the faster that becomes. And this is because we have essentially the ability to both burst on our organizations, and it's done by shards. So the more orgs you have, the more parallel. So it's 10 calls per second per org. I got a customer that 40 orgs, that's 40 times 10, right? Your source IP does matter, but you can queue up to 100 queries per org. So if you had like 8, you could almost technically do up to 800 calls per second if you've done it optimally, right? And so that's just a very powerful way to show the use of it. Now, not a lot of customers or a lot of developers will come up to me and they're like, "This is great, but I don't want to have to retool. AsyncIO is kind of a pain in the butt to deploy, right?" But this is the way I see, or we have a lot of customers doing it now, where you'll have this script, right? Essentially, all you have to do is insert your code here. On the top here, you're going to basically prefetch everything. I mean, everything. So like maybe you're touching 3 networks, download all of them, right? It doesn't matter because it's essentially a fraction of a second different. You do your regular script against the memory object. So it's going to be like, device inventory. You can say, okay, for this org, do this, get only switch ports, but you do it all based on memory. So this section here is literally, milliseconds because it's all RAM based. Now, the top part just forgets, like just for querying, but like how do we commit those changes? So ActionBatches is another repo that I'll provide to you guys, which also allows you to say, okay, I want to queue, much like future object, but I want to commit this change, but in a batch, right? So I want to write a bunch of switch ports, I want to change a couple of RF profiles, but I don't want to do them sequentially. You're going to put them in a big batch, then you're going to pickle it, which means that you take that list of all the commits you want to do, save it to disk. So that way, if you do have an error, you can go just restore that and recommit it. Or you can see what you pushed, right? And then after you do that, you actually execute it, and it will execute as fast as it can in a batch form. So for those that haven't used ActionBatches before, I'm going to link to a repo that will help you. It's a very easy way to execute it. So, for the essence of time, I want to kind of talk about a couple hacks, and then I'll give you this slide here, which you can screenshot in a second, that has all the repos. But there are many other things that this provides, right? So AsyncIO has little nerd knobs to do things like QoS, right? So we have customers that are doing like a backup script that runs daily. Now, if I run another script at the same time, you don't want them to clash. But if you look at here, this is how you configure a regular dashboard object for Python. And there's not a lot of options, right? It's basically where do you want to go, and everything else is sequential. AsyncIO, you can see that there's a maximum retries, retry wait time, a maximum concurrent requests. But you can also do the retry time limit. You can actually back off. So if you have a less priority script that's doing a backup, you want to back off maybe 5 minutes, 30 minutes, right? It's non-critical. Where if you have something that's pushing a change, you want to have it right away. It's a very easy way to tweak that. Now, there's other ways you can do it too. Like if you do a lot of heavy queries, like if you're querying an endpoint, like I want to look at CDP LLDP neighbors, which means you're touching a device. You may want to take that massive, the trash packing, and you shuffle it. So you're not putting all the like-minded endpoints right next to each other, which are going to take more time, and it speeds things up considerably. So definitely take a look at this. The one thing I'll mention, so is this batch helper. So definitely screenshot this. The AIO benchy at the top there, that's what I just demoed. That's going to be the log checker, as well as, log analyzer, as well as that API backup script. You can feel free to take a look at that and see how it's written. Feel free to reach out to me if you have questions on integrating it. This is written by one of our PMs. This is the action batch helper. This is amazing, right? You basically leverage the same API that we have, but you do like db.batch like networks.get whatever. So instead of saying networks.get ports, you do batch.networks.get ports, and that gives you that future commit. You put it all in a list, and then you basically say point it to ActionBatcher, and you can do it in batches of 100. It'll do it sequentially, atomically, and you can do thousands of records incredibly, incredibly fast. So very much like how AsyncIO helps you on the get, the ActionBatch helper helps you on the commit. And including that pickle allows you to save that commit before you implement it. So now you have the ability to replay that action if you need to. And then, this is an actual use case we had with a customer wanted to look at, their 43,000 switches every 6 hours and look for bad cables, thermally impacted fiber. And we were able to do this using the script a lot faster than if we did just look at the sites that had problems. And then, of course, we also have a collection of automation scripts that are, on our Meraki GitHub as well that you should take a look at. So that is definitely my session. Did you guys have any questions, or did this make sense? Yes. Correct. Yeah. So yeah. So there's this is why it's a kind of a hack, because we changed that from 5 per second to 10 per second per org, right? So that's usually what people expect they're going to get. But as you saw, if I just run a sequential script, I'm getting like 1, right? And in the US, I'll get like 4 calls a second, but we're close to that 10 calls per second. So what AsyncIO does is it shotguns everything in the same HTTPS session, right? So you're not doing like, okay, every API call, you're going, okay, great, give me that network. And they shut down that TCP session, do the next call, you stand it up again. There's like time in that breakdown. Plus our shards will actually queue stuff. So if you get enough API calls into an org before the rate limit hits, you can actually queue 100 calls. And that's where we're getting that amplification. But you can only do it if you trash pack all of them at once, right? Because within a second, it's going to start slowing you down. So if your calls, or if you're just like brute forcing trying to crash the server, you're going to be rate limited. But you can hit 100 calls per second, or you can queue 100 per org before that kicks in. So the idea is you get all that in first, you get all the data back, and then you process it. So, and then you can do it in bursts. So you wait 15 seconds, do it again. That way you're also not having a script that runs for half an hour that may impact another script. Yeah, so it's a little bit of hack, and every time it gets a little bit faster because we have something called an API proxy, right? So if you query, api.meraki.com, you're going to essentially a proxy that's going to say you should be on this shard, or it's going to route the API queries, where previously you'd have to go directly to the box. Now that used to be our gatekeeper, right, where we had a 10 calls per source IP limit on that box. But now that has been broken up. So this is Meraki perpetually iterates. We moved that limit to the org itself, and then I was demoing it, and I was going from like, oh, I can get you 25 calls a second. And I demoed it and hit 60. And I was like, this is awesome. If you have more, you can actually, like the tweak number, the concurrent sessions, I'm limited it to 100 calls concurrently. So if you have one shard, you're not going to break it. But my customer that has 40 plus, or one of our customers that have 40 plus, you can go up to 300-400 calls concurrently. And if you shuffle it, you'll hit north of 100 calls a second. So, and this is really good for reporting. I've got customers that want to query like port usage, change control, change logs. And as your network gets larger, API becomes less and less scalable. But this is one way to kind of optimize it or see that efficiency resolved, right? So this is the this is the basically what we want to do is like you get the data, you run your log or your logic, and then you commit those changes. So that the starter script on this page, so you'll see this starter script. Download that and run it. It'll look at your existing orgs that you have access to, and it'll pre-cache everything. And you can go into that script and say, I only want to look at network clients, or I want to look at switch ports. You can pick and choose what data you want to cache, because you may not want to cache all your switch ports if you just want to change group policies or something. But that's some great tips and repos to play with. But yeah. All right. So for those that haven't been scanned, we do have a giveaway. So get your badge scanned to get a ticket. Or are we done? Yeah. Okay. All right. Anybody that hasn't been scanned? Yeah, and definitely subscribe to this starter script repo. This is the one that's going to change. I didn't submit. It's going to have the action batches built into it. So the idea is you want to be able. It's going to have eventually a configuration file where you can pick and choose what data you want to pre-cache, and then it does everything else for you. And yeah, I just didn't have time to do it before this Cisco Live. But all right, as soon as we get everybody scanned, we're going to do the giveaway. And for those that haven't seen it, we're going to be giving away a 4K Fire TV, which is super convenient, especially if you're traveling. You can now plug it in at the hotel room. All right. Yes, thank you. All right. So everybody have their tickets ready. All right. And the winner is 346587. 587. Hey. Let's see. Thank you so much. All right, guys. And with that, it concludes my session. Thank you very much.